Hey everyone, today I'm going to go through the first part of the 162 final exam for fall 2019. So that will be question 1 to question 10 since there's 20 questions. So first, potentially useless formulas. These will come in handy from time to time. Um, Especially there's some questions, the half angle formula here is pretty useful. On to number one. So first we're given two vectors and try to find the angle. So we can use either the dot product or the cross product to do this. Either one should be fine. So I'm gonna use the dot product here. If I say this is A and B, then if A dot B would equal to the magnitude of A times the magnitude of B times the cosine of the angle in between. Sorry, changing something. Should be better. So here we get uh 3 0 -3 dot 1 -1 0 will equal to the magnitude of this would be square root of 3 squared plus 0 squared plus -3 squared times square root of -1 squared plus 1 squared first would be, but doesn't matter here. That will times the angle in between, cosine of the angle in between, and then dot product. The first times the first and second. The x it's the sum of the each components. So it will be 3 plus 0 plus 0. So it would be 3 on this side. And then we have 9 and 9 will be 18, root 18 here, times root 2 times the cosine of theta. And here 18 is 9 times 2, and root 9 will be 3. So this equals to 3 root 2 times root 2 times cosine theta. And we can cancel out 3 on both sides, and root 2 times root 2 is 2. So 1 equal to 2 cosine theta, and bring cosine theta on this side, divide 2 on both sides. Cosine theta is a half, and here from the unit circle, or anywhere you like it, you should be able to get that theta is pi over 3. So anywhere you see cosine of something is a half, you should think the 30-90 30-60-90 triangle. So 30 degrees here, 60, and right triangle. Then it will be 1, 2, and root 3. When way 1/2 root 3 over 2 and 1. So that's a pretty neat triangle to remember. So then we can get the angle in between is E, 3 pi over 3. Oh, let's clear the screen here. And first question is E. Let's move on to the second question. So we're here to find the parallelograms, the area, and we're given the vertices. So we can find the area by doing let's see, the area will equal to um, the vector of AB cross AC, or any way you want it. It can be AC cross AD, or so you're just trying to get the same vertices on both and the two different points, I think. So let's draw a parallelogram and we can see. Give it A, B, C, D. And when you do the cross product, you're technically cross product is the magnitude of the vectors. So if A cross B would be A times B, the magnitude times the sine of the angle in between. So here, if I cross AB and AC as the two vectors, then I would have the magnitude of AB times the magnitude of AC times the angle in between. And we'll notice that parallelograms area is by the base times height. So let me draw a height here. And the height, so here, let me write it down, equal to base times height. And the base, let's say the AC is the base. So it will be AC times the height here. And the height here, we can get this from this triangle, in which the hypotenuse is AB. And then the hypotenuse is AB, then AB times the sine of the angle in between, then will give you the height. So that's why when you find the area of the parallelogram, you can get the two sides. You can just cross those two, and you should be able to get the area. So let's move on from that. So AB cross AC would be 1, 1, 1. Cross 1, 2, 1, since A is 0, 0, 0. So now, so we do cross product, so ignore the first row. Then it would be 1 times 1 minus 1 times 2 will be negative 1. And then ignore the second row. 1 times 1 minus 1 times 1, and negative that will still be 0. And ignore the third row. It would be 1 times 2 minus 1 times 1 would be 1. And when you do the cross product, you actually have to do the magnitude of this. So the area equals the magnitude of this, which would be negative 1 squared and plus 1 squared, and square root of that, which would be root 2. And that would be answer B. And let's move on to question 3. So question 3, we're given a triangle region in the graph, and so trying to form squares out of the cross section here and calculate the volume of that solid. So first, always draw XY plane. Make sure you know what's going on. So point A, the first point would be 0, 0, the origin. And then the second point, 0, 1. Say that's 1 here. And the third point is 2, 1. Be somewhere along this here. So then this triangle region is like this. And now that should be parallel to the x-axis. So now we can, since it's squared perpendicular to the x-axis, so it should look something like this, with the sides equal to the height between these two lines. So we can do a integral from that. The integral, let's not worry about the bounds right now, but so it would be the top minus the bottom, and the square of that would be the area of a single square. So the top is y equal to 1. So 1 minus the bottom of, so we can, there's 2 points on this line, 0, 0, and 2, 1. You should get y equal to half of x. So that will minus half of x squared will be the area of a single square, and then we can add that to dx. And now we look at the bounds. It's x is from 0 to 2. Add it here. And now we can simplify this into integral 0 to 1 of 1 minus x plus x squared over 4 dx. And now we can just integrate this one by one. And integral 1 is x. Integral of x is half x squared. And this would be x to the third divided over 12. All of these will be evaluated from 0 to 2. So plug 2 in, fundamental theorem calculus will be 2 minus 1/2 of 4, 2 squared, plus 8 over 12, and minus 0, 0, 0, since it's all dependent on x, it will be 0. So here, 2 and 2 cancel out. We are left with 2 over 3, which is choice D. And as we can see here, 3 is D. Let's move on to number 4. Number 4 is a little bit tricky. You should be familiarized with the sign graphs. No matter what the coefficient inside is, you should be able to calculate the period and try to graph it. So let's try to graph this first. So first, cosine graph. Since it did not shift horizontally or vertically, it just changed in the period. It's just cosine graph should look something like this, and the curve up and down, with the period being pi now. So pi will be somewhere here. 2 pi will be here. Pi over 2 will be here. I should really extend this. And this should be pi over 4. And sine, since it did not get shifted horizontally or vertically, should look something like this. And with the period now reduced to pi over 2, so it should look something like um think it should be, hold up. It should go through here and up. And we're really curious only about this part where it's pi over 4 from here to here since it's a bound. But try to reproduce something like this. And let me show you what it actually looks like here. The blue is the cosine and then the red is sine. And we can see that from 0 to pi over 4, it does look something like that. And just a reminder, it does intercept at pi over 12. And you can get that by just setting the two equations equal to each other. So sine 4x equal to cosine 2x. And then you can do something with this from the front where it's the potentially useless equations. You can do something like the double angle formula for sine x for 2x. So 2 times 2x, which equal to 2 sine 2x cosine 2x equal to cosine 2x. We're not interested when cosine equal to 0. So we can divide cosine 2x from both sides. So we can get something like sine 2x equal to a half. And I divided the 2 over. So you could get 2x equal to pi over 6. That's 30 degrees from the 30, 60, 90 triangle. And then x would be pi over 12 where it intersects. That's pretty important since when we look at the graph, so the first part before pi over 12, it is cosine 2x being on top of sine 4x. And then after from pi over 12 to pi over 4, it's the reverse. So with that, we can write the two integrals. We first is from 0 to pi over 12. And we can have, so we know that the cosine is on top. So cosine 2x minus sine 4x dx plus the second half of that would be pi over 12 to pi over 4 here. And then is the other way around with sine 4x minus cosine 2x, and that will be dx. And should be pretty easy integration since there's only really one term to each. With this being half of sine 2x minus a fourth of negative cosine, which will make this plus cosine 4x. This is evaluated at 0 and pi over 12 plus the same integration but just negative on both sides. So negative cosine should be 4 here. Fourth cosine 4x minus half of sine 2x, and this will be evaluated from pi over 12 to pi over 4. Let's see. And then we can plug these values in. So pi over 12 plug into here will be sine of pi over 6 with a half in front, plus plug into here 4x is a fourth cosine pi over 3, and the 0, so 0 plug into sine will be 0 anyways, so it'll be minus 0 actually. And minus 0 here would be a fourth of cosine 0, plus now let's evaluate this. So a fourth plug into here would be negative 1/4 of cosine pi, minus 1/2 times the sine of pi over 2. And all of this minus the negative, so it'll be plus plus a fourth of cosine pi over 3. It's gonna be really hard to see, pi over 3, and that plus again of 1/2 of sine pi over 6. And since it's the plus in front, so the parenthesis doesn't really matter here. And so we can get a few things out of the way. The 0 can go. Pi, so let's start from here. Be 1/2 times sine of pi over 6 will be a half, so it's a fourth. Plus cosine of pi over 3 is also a half. Again, it's the 30, 60, 90. So there would be 1/8 here. Minus 0. Minus cosine of 0 is 1. So minus 1/4. Minus pi, cosine of pi will be negative 1. So it will be actually plus 1/4. Minus sine of pi over 2, which is 1. So minus 1/2 plus cosine of pi over 3, which is here, which is 1/8, plus sine of pi over 6 over 2, which is here, which is 1/4. So now the plus and minus of 1/4 cancels out, and a fourth plus a fourth is 1/2. So that can cancel out with this 1/2, and you left with 1/8 plus 1/8 would be 1/4, and the answer would be D. Let's move on to question 5. So again, asking somewhere between the two graphs, so recommended to just graph them first. So x squared and x 2x. Really interested just in the first quadrant. And when you plug, you make x squared equal to 2x. You can solve that. That's 2, and 4 where it intersects. So really, this should be um, it's rotating around the x-axis. It's pretty important. So we can get this would actually would be easier to use um, washer method, which is what I would prefer. But since we are required to use cylindrical cells, we gotta switch this over to dy, as all of these are dy, and then it will be the integral of 2 pi r h. Now if we can try to see this from maybe this perspective, so with x-axis on top, then we can see that it would be this curve is on top, and then this curve is on bottom for this area. So we can rewrite this in relations to y. The curve would be x, you could do y root of y, and the line would be x equal to half of y. So that would be the h of the cylindrical shells being oriented this way. And the height would not be over here. It would just be this way. So that would be the height, and then the r would be the y along here. With this y, you can get the height would be this minus that. So we can rewrite this with dy, and it would be from 0 to 4, of 2 pi. R is y, and h is the curve top minus the line on the bottom, dy, and it would be D, option D here. As we can see. So for these questions, I do really recommend try to graph these first so you can see what you're really dealing with. That too. Whenever it's something on the coordinate system, graphing it is not a bad idea. And we will start this question by graphing it too. So x and y axes, x equal to 0 is the y axis, and the curve is a exponential. So let's just draw something like this, and we have an arbitrary value of c. So x equal to c would be along this line. So we're really rotating this area along the x-axis. So it would be like something like this. So this is a pretty straightforward disk question, which and then you can solve for the volume. Then you can just get c from there. So we can start from the bounds of 0 to c, and it's just pi r squared. Pi r being the top minus bottom of the x-axis. So be e to the 3x minus 0. So it gives e to the 3x squared dx. And if you're unsure what this is, you can always think that to the when you square this, it's just e to the 3x times e to the 3x, and then you can get e to the 6x. Since when you times the two exponents, it will be plus it's the sum of it on top, and then we can just move the pi outside. Then we will have a integral looking like this, and then chain rule it. Then you would get something along. You get pi of 1/6 of e to the 6x, evaluated at c and 0. And let's move, actually, let's do one more. So pi of e to the 6c, plugging c in, minus pi of e to the 0. E to 0 is 1, so that's just pi over 6. And all of this is equal to y here, with the value equal to y. I mean pi. So pi is over here. Okay, cancel out pi, divided by pi on both sides. You will get 1 equal to, let's see. Oh, yes. Y equal to e to the 6c over c minus 1/6. Move the 1/6 over, and times 6. You can times 6 on both sides. Doesn't matter how you solve this. You should get e to the 6c. That's a 6. Equal to 7. And now natural log both sides to get the e. So 6c would be ln 7. Then c would be 1/6 natural log of 7, which is choice C. And that will be the answer. And now move on to question 7. Looking at this integral, first thing popping in your mind should be by parts. So we can have u dv equal to uv minus v du. Let's write down top. This would be equal to uv minus integral of v du. And so you should have learned something about Liatier of choosing which one is u and which one is v. And this one, I would choose the natural log of x being u, because when you do the du, you would get 1 over x, which is pretty simple. But when you try to take the integral of this, set it as dv, and take the integral trying to get v, you get something not so nice. So now we got the du, so that means that x to the half power dx is dv. Then v would be this integrate this, which is 2 over 3 times x to the 3 over 2 power rule, and then we can plug all these values into this formula. So uv on x times v here be 2/3 x to the 3 over 2 power minus the integral of the same bounds. This should be evaluated at 1 to e, minus so v du 2/3 x to the 2 power times du, which is 1 over x dx. And let's just look at this first. So x to the 3 over 2 power is x to the 2 over 2 times x to the half exponents. So it would be, that would just be x to 1 would be x. So then that x would cancel out with the x in the bottom. So you would left with just 2 over 3 times x to the half, which is just root x. So this integral would be pretty straightforward. It's just this, which would be 9/4 x to the 3 over 2 power evaluated at 1 to e. And now let's evaluate this first. So let's start from over here. So e, plug e in, L and e is 1. Then you would have 2 over 3 times e to the 3 over 2 power minus ln of 1, which is 0. So and then this part wouldn't matter because it's 0 times something. It's not 0 times 0, then we don't care about it, so that would just be 0 here. And minus this part, so minus 4 over 9 of, that should be, plug it in, e to the 3 over 2, and minus would be plus 4 over 9 times 1 to any power is 1. So now cross out the 0. We see this is actually just 9 over 6 of e to the whatever power that is, the same thing. So it would be 6 over 9 minus 4 over 9 would be 2 over 9 of e to the 3 over 2 power plus 4 over 9, which will be b here. And 7 is b. Let's move on to the partial fractions. This should be pretty straightforward. We can see that there's really 2 parts to this partial fraction. It's x squared and x squared plus 1 squared. So starting with x squared, it should have the simplest factor of 1 over x plus 1 over x squared. And since the simplest factor is only power of 1, just start with a on top, and with a repeating factor, have the same power of constants, and you have b on here on the top of x squared. And the second part, again, it would be, this would be the simplest factor plus the squared. And we can see that the highest power is actually second power here, so we need something along the line as ax plus b, but since a and b are taken, so we go as the next will be cx plus d. And with a repeating factor, we just do new constants with ex plus f. It'll be a big pain to solve this from that partial fraction expansion, so they just give it to you here. It will be option E. Um, as we can see here, A is E. Move on to 9 using long division. So long division, I like to write the rest of the term out even as 0 divided by x plus 2. So starting on this term, um, starting on here, we will have an x to fulfill the power. It would be x squared plus 2x minus that would be 0 minus 2x plus 0 plus and then trying to fulfill the 2x here will be actually -2, and it would be 2x minus 4 with a 4 left over. So the fraction on top actually equals to x plus 2 times x minus 2 plus 4 over x plus 2. So this part, you can separate these two fractions, one here and one here. And then you would have x minus 2 plus 4 over x plus 2. As in this fraction, the x plus 2 on top and bottom can cancel out. So, and then you just take the integral of this. It's pretty straightforward. You get x over 2 minus 2, x squared over 2 minus 2x plus 4 ln absolute value of x plus 2 plus c. Just take the 4 out for this one, just take the 4 out. Use a u sub of u equal to x plus 2 and you get something like this, which is option A. As we can see here. Last question for this video, which of these statements is true? So really trying to get the different trig functions. So first we look at trigs, just look at the odd number powers. So in this one, tangent is odd. So you can make 2 of the 3 tangent powers go into secant. You end up with so tangent squared equal to secant minus 1 squared minus 1. Let's see. Yeah, that makes sense. So you can get this from sine squared plus cosine squared equal to 1 and divide both sides by cosine squared. So you can plug this into here and you get something tangent x of secant to 6 minus tangent x. Hold up. Yeah, this can work too. But that's not the option you're looking for. Hold up. So there would be 1 plus tangent squared equal to secant squared. Then you can try to substitute secant squareds into tangent as if you u sub tangent x, du is secant square x. So if you transform one of the secant square x into tangents square plus 1, then you can u sub and there will be a du here. So this is true. You can do that. So number 2, same thing. Look at the odd power here. Since cosine is odd, and let's see if this actually works. So if u equal to this, then du equal to 3 cosine 3x. So the odd power here will suffice because you can take this and become cosine 3x times cosine squared 3x times cosine squared 3x. Change the 2 cosine squared 3x into sine 1 minus sine squared 3x, and you can u sub this in because there will be a cosine 3x in every single one of those terms. There should be 3 terms. I will not write that out. So both of these are true. And move on to the final here. So this actually, one of the equations on top will come in pretty handy here. As we can see, sine square of any sine squared theta equal to this. So let's go back. Sine square x equal to half of 1 minus cosine 2 theta. And then we can substitute this into here. Then it will be the integral of, can have 1/2 outside, 1 minus cosine 2x, cosine 2 theta d theta with 0 to pi over 2. And integrate this, give you 1/2 of theta minus 1/2 sine 2 theta evaluated at 0 to pi over 2. Plug in values, you will get pi over 4 minus, so pi over 2, plug into here, we sine of pi, which is 0, so minus 0, and then plug in 0 in, so it will be minus 0, and sine of 0 is also 0, so it will be plus 0. So you get the integral equal to pi over 4, which you make the third statement true, and that will be all of them true, which make it E, as we can see here. So this will be the first part of the video. I will link the second part of the video from question 11 to 20 in the description, and thank you guys for watching.